How do you get the most out of CloudWatch Alarms? Last time we covered CloudWatch metrics, and with CloudWatch metrics you can get out-of-the-box metrics for AWS services, and you can create your own custom metrics for technical data points as well as business-level metrics. But in this episode we're going to discuss what can you do with alarms. So what are the different types of alarms? How do you create them? What can you do when your alarm gets triggered? We're going to go through a few useful examples, types of alarms you can create, and we'll also talk about some of the drawbacks of CloudWatch alarms and tips to overcome them. My name is Owen, I'm joined by Luciano, and this is the AWS Bytes podcast. Last time out, we discussed CloudWatch metrics, and one of the most important things you can do with those metrics is to create alarms. And that is our topic for today. Luciano, what are the different types of alarms you can create with CloudWatch alarms?
Yeah, there are essentially two types of alarms. What we call metric alarm is the first time, which is basically an alarm based on a single metric. And if you want to make it a little bit fancier, you can also use mathematical expression to basically enhance the value that you extrapolate for the metric and do some calculation with it. And another type of alarms is what we can call composite alarms. And those are effectively what the name says. So you take different alarms and you combine them together, and you can build additional alarm on top of that. So as an example, you can say, if this alarm fire and this other alarm fire, I want to fire another alarm. What do we want to say first? How do metrics work? Maybe we can give an example of how to create one alarm.
Yeah, that sounds good. So there's a couple of things you need to specify when you create one. First of all, you pick your metric. If we're just talking about a simple metric alarm example, let's say we want to monitor CPU usage on our EC2 instances. Then we'll pick the metric AWS/EC2, that's the namespace, and the metric is CPU utilization. So once you pick the metric, then you need to specify your threshold. So are you going to put an alarm on 90% utilization, for example, and you pick then a comparison operator, greater than, greater or equal to, less than, and then you can specify the period. So we know from our last episode on metrics that you have a period of, say, 1 minute, 5 minutes, 15 minutes. So what period do you want your alarm to be based on? And then the statistical function. Are you looking at the average over that minute, the maximum? And then you can specify a number of periods. So what you're doing then is you're saying to CloudWatch, I want you to look at the average CPU utilization over 3-minute periods, for example. And then you can specify how many data points of those 3 will trigger an alarm. So you could say 3 out of 3 if the threshold has been breached for 3 successive data points, then alarm, or 2 out of 3 or 1 out of 3, or you could just have 1 data point. It's completely up to you and how sensitive you want this alarm to be. What that gives you then is an alarm on CPU utilization if it's above or equal 90% on average for at least 2 minutes of the last 3 minutes, say. And then the last thing you need to be considered is if you want to be alerted. So if you do want to be alerted, you'll probably need an SNS topic, and alerts will be sent to that topic, and then you have a lot of options in terms of what you do with those messages. Otherwise, you can just see the messages in the AWS management console or from the CLI. It's not ideal, not very reactive. You have to be a lot more proactive. So you have to get the balance right, I guess. Get the right amount of noise, but not get too noisy. We give one example there, right, on CPU utilization. Are there any other use cases you can think of that call to mind?
Yeah, just a few that come to mind are, for instance, if you're monitoring a load balancer, you can check the latency and see if that latency is going above a certain threshold for a certain amount of time. You can also create billing alerts. These are probably some of the most useful ones and some of the ones you should create as soon as possible. So with those, you can monitor if your projected expenditure is going above a certain threshold. That probably is going to be like your billing budget or something like that. And you can use that to stop some services and see maybe if there is a bug that is causing you to spend a lot of money on AWS and react before that bill becomes very, very big. And other ones, for instance, that I've seen to be very, very useful when building APIs, you can monitor API gateway and see the number of 500 errors. And you can have alarms that check maybe if you have an increased error rate that way. And those can be useful to spot bugs, for instance. So I think we have more examples in the next sections, but I think those are very good examples to understand just different kinds of alarms that you can create not just for application errors, but also for billing or for latency. So it's a range of different things you can do with them.
Yeah, it might be worth mentioning that we think about alarms as alerts, but alarms are always in one of three states. So the state you want them to be is in the okay state. The state you fear the most is the alarm state. And then the third state is actually somewhere in between. That's called insufficient data. And that's the state it gets into if you don't have enough metrics for CloudWatch to be able to determine which state it's actually in. So often when you create a metric for the first time, if you don't have enough data, it'll end up in insufficient data. So that's what that's about. And any alert, so if you're talking about SNS alerts or anything like that, you can alert on any state, not just the alarm state.
Yeah,
so you could say alert me when it goes on alarm, but also alert me when it goes back into okay.
That's a very good clarification, because the naming can be a little bit confusing. I think generally when we talk about alarms, we think about the alarm state, so when things are bad. But in AWS CloudWatch, the term alarm is just that configuration, and then you need to look at the state to understand.
Yes.
Are we in a good situation? Are we in a bad situation? Or you can, as you said, you can even look for, are we just recovering from a bad situation? Because you can create alarms that tell you, you can create notifications that tell you, okay, you were bad before, you were in an alarm state before, and now you're finally back into okay state. And if you use things like chatbots, we'll mention some of them later on, that can be very useful to see, because maybe if you have a noisy configuration, sometimes you realize, okay, this thing triggered an event, I'm seeing an issue, but then immediately afterwards I see that the issue resolved itself. And that means you don't really need to do anything. Maybe you can tweak a little bit your configuration to reduce the noise, but you don't have like an immediate need to fix anything.
What do you think is the best way to actually get notified then, if you want to react in a reasonable time frame and you want to also avoid noise? What's the best tooling that you can apply for notifications?
Yeah, so there are different ways that you can basically be notified when the state of an alarm changes. And probably the most common that I used to see in the past, is not necessarily the one I would recommend, is SNS to an email. So you configure your alarm and you say, every time this condition happens, send an SNS event, and then from that SNS event you can dispatch the event somewhere else. So the most common one I've seen in the past was email, but I'm not a big fan of that one, because I remember a few years ago when I was trying to use this, you will literally get a big wall of text on an email, and it's not the most intuitive way of understanding when you have to go in an emergency and try to fix something. Like, it takes a while for you to process even what's just written there in the email and make sense of it. Yeah. So there are more sophisticated ways today, and one is like totally custom. You can just send the SNS to a Lambda, and then you can do whatever you want with it. And that really depends on how you structure your teams and your operations. For instance, if you use tools like PagerDuty, you could use the Lambda to send the event to PagerDuty and then manage the incident that way. Or you can build the Lambda to integrate with other systems that you might want to use. Another interesting way, if you, for instance, want to use a chat platform, because maybe you do the kind of operation based on Slack or Teams or something else, there is, of course, you can do it with a Lambda, you can do it yourself and build the integration that way, but there is a tool from AWS called AWS Chatbot. So you can send the alarm from SNS to AWS Chatbot, and AWS Chatbot has already built in a lot of nice things, like you get a very good user experience. When you integrate it with Slack or Chime, you get very nice preview of the message describing what the incident is about. The only issue is that, as far as I know, right now, Microsoft Teams is not supported.
Yeah,
and I've been working in many companies using Microsoft Teams as the primary system. So in that case, you are a little bit on your own to find other tools or to write your own integration.
Yeah, I really like the chatbot experience, actually. It's pretty easy to set up once you've got your topic. Chatbot is pretty slick for setting up, and writing your own integration into Slack has become a little bit more involved. You have to create an app now. You can't just fire data at a webhook. At least they don't want you to. So AWS Chatbot has kind of solved all that for you and gives you a really nice message.
So what do we do after we get notified? What can we do with that in general?
That's a good question. So you can have all these, I suppose manual intervention is going to be completely dependent on the kind of alarm you're dealing with. But there's also some automated interventions. So apart from SNS, there's some other actions you can take that are actually like automated remediation. And now you could, like you say, you can use SNS to Lambda, or you could target, systems manager automation for remediation. There's so much you could do there. But out of the box, if you're talking about EC2 metric alarms can also trigger EC2 actions. So you could say if your CPU utilization is getting too high, then reboot the instance or terminate the instance. And if you've got some legacy application with a memory leak and that's your only option, I guess that's one kind of path you could take. You can also trigger an auto-scaling action, and this is probably where a lot of people may have used alarms in the past, maybe without even realizing it, because alarms and auto-scaling kind of go well together. So you're scaling essentially in response to the observation of a metric breaching a threshold. So that could be an EC2 auto-scaling group, and that could be based on number of requests or some of your load balancer metrics, but it could also be an ECS service auto-scaling. An example of that before, and I think we've raised this one a few times, is if you've got a pool of workers doing some jobs, batch processing, say in an ECS cluster, then you could scale based on the number of messages in a queue, like an SQS queue that they're pulling their actual jobs from. And that's a good way to handle it, because you could have, a standard default, maybe a 5 or so workers working away by default. But then if a large volume comes into the queue, you might want to scale up to a certain limit. And alarms are really good for that. I don't use a lot of the many features in Systems Manager, but I know as well there's some things you can do there if you're using some of the incident management features. Like you can create an ops item if you're using Ops Center, and you can also create incidents in Systems Manager. So there's quite a lot you can do. But I suppose one of the challenges with alarms, and one of the reasons people probably shy away from them, is because people have experience with very noisy alarms, and it can be very difficult to actually know what's going on when the default state is that things are always in alarm, and then people just stop trusting the value of them. So composite alarms is something you mentioned at the start. Do you want to talk about maybe some examples where you use composite alarms and how they compare to just the simple single metric alarms?
Sure, yeah. Before that, I like what you said, because there is a quote that I really like, that is, when everything is an emergency, nothing is an emergency, right? So I think that we can say the same with alarms. Like if the alarm system is always noisy, you stop being concerned, right? That becomes your norm, and you are not really trying to react anymore and fix things. So that's something to be aware. I would also caveat that at the beginning, when you start to set up your alarms, it's probably a good idea to try to be a little bit noisy, so you can find actually the threshold that works for you. So initially, probably there is a little bit of a tuning phase where you try to find what your threshold should be like for you to actually be effective. Anyway, back to composite alarms. I think composite alarms are actually relevant to this topic, because they can be one tool that you can use to make things a little bit less noisy. And one example I have is that it's very common, for instance, when you build APIs with API Gateway and Lambda, to have individual alarms, both on, for instance, on Lambda failures, but also 500 errors on API Gateway. And if you have both, what happens when a Lambda fail? You get a 500 on API Gateway. So you're basically alarming twice. And one way that you can remove a little bit of noise is that, of course, you need to create both alarms, but then you are going to fire an alarm event on SNS using a composite alarm. So that basically means that you take the two alarms together, you combine them with a Boolean expression saying, if either one or the other, for instance, fire, then fire the other composite alarm, and then you only receive a notification for the composite alarm. So this way you are effectively flipping two alarms, but being notified only on one of them. I don't know if you have other examples when composite alarms can be useful, but I think they are just a nice way to reduce noise. Maybe you can also build more complicated rules. Maybe in some cases you can use that to combine different metrics, and then maybe only when you see a certain combination of metrics happening, then it really makes sense for you to alarm. This is maybe another example where composite alarms can be used.
Yeah, it's very flexible in that way. One of the other points about, I suppose, the usability. So noise is one factor that's important for usability, but another one is that we've frequently talked about separating lots of different services and applications and environments into different accounts. So the question then becomes, how do you keep an eye on alarms and metrics across multiple accounts and multiple regions even? And it is possible to do this without having to open dozens of tabs in your web browser, dozens of containers, or whatever way you can manage different accounts. Because cross-region metrics you get out of the box, so you can view alarms and metrics from the console already. But if you're talking about cross-account, you just have to do a little bit of setup. So for every account that you want to share metrics from, you just need to say, okay, I'm going to share it with this central monitoring account, and give the account number. And then on the monitoring account side, you just say, okay, I'm going to pull in metrics from these 20 accounts across my organization, or all accounts across my organization. And then you can start to look at things from one dashboard and from, a single pane of glass, essentially, without having to log out and log in or switch tabs. And that makes it a lot easier. So I think that's worth mentioning in this multi-account world. So maybe it's worthwhile if we talk about some more useful use cases for alarms, right? To see if we can give some inspiration for people who are maybe not using alarms extensively and can start getting cracking and making their lives easier and maybe reduce the operational overhead. That's what they're for, after all, right? Mm-hmm. Especially if you can predict errors before they can happen. Where will we start? We talked about business metrics in the last episode. Mm-hmm. So we've given examples about API Gateway, EC2. What kind of alarms could you create on business metrics that might be useful?
Yeah, I think the ones we mentioned in a previous episode were, for instance, the number of sales per day. Again, our favorite e-commerce example. Like I suppose in some e-commerces, the amount of sales tends to be quite predictable. So you could create a custom metric and then an alarm to see when that value goes a little bit outside your expected amounts, either lower or way higher. In both cases, maybe you need to do some action, so it's worth to be alarmed as soon as you see that event happening. And another one that I used in the past and was very beneficial to me is to monitor the number of people that are logged into an application. Like in some application that can be predictable enough, I would say. So you can define rules, or even sometimes you can just say, let me know when this value is 0 for a long time. And this is actually the one I used in the past, and that one helped me to figure out an issue that was present in the login system. Actually, it was more in the session system than the login system. But anyway, having that alarm was good for me to see that people were not able of logging in for a long period of time. So I could figure out there was something wrong, investigate, find the issue, fix it, and bring everything back online. So these are examples of business metrics that you can leverage to build alarms and then be more reactive and prevent incident from happening for a long time before you realize and you can fix them. Again, we mentioned API Gateway and Lambda for more technical ones that you can use to capture specific bugs. So when the code is actually throwing errors, similarly, you can, if it's timing out, you can consider that an error. The problem with all these ones we just described is that they tend to be reactive. So it means the issue happens first. Then you're probably giving a disservice to your users because of these issues. And then you try to rush and say, okay, let's fix this because our users are currently, seeing unexpected results and we don't want that to happen anymore. But the question could be, okay, can we do something in advance? Can we predict when something is about to happen and maybe fix it before it's too late, before it's impacting the users? And there are two things that you can do. One thing is that you can use, for instance, in the case of timeouts, right? Lambda timeouts. You could create an alarm that looks for your Lambdas getting closer and closer to that timeout. So for instance, you could say, trigger this alarm if you get 90%, if your Lambda are taking 90% of the time that has been allocated for that Lambda. So if you are close enough to the timeout, but you are not hitting it yet. And this is something that, for instance, it can happen if you have n+1 queries in a Lambda, right? As your database grows, the time for executing that query will increase. It will get longer and longer. So initially, you will have plenty of time to stay within the timeout, but over time, maybe you will see that time increasing and getting closer and closer to the timeout. So having an alarm there can tell you that this is becoming a problem before your users will start to see an error. So that's something that can be very, very useful. And another thing you can do, I'm not sure if we mentioned it already, but there is anomaly detection based alarms that you can use to basically see if your current metrics are going outside the norm. You can use that, for instance, again, for Lambda durations. If suddenly you see your Lambdas taking much longer, not necessarily getting close to the timeout, but just taking much more time
starting to
than
exhibit
usual.
unusual behavior.
Exactly.
Yeah, that's good. Yeah, I think you kind of, for that one, you specify it's like a standard deviation. So you specify a band and how much outside the average you want to be your anomaly detection band, and that can trigger your alarm.
And one last example I have is for asynchronous computation. For instance, I don't know, when you have a queue and a pool of workers, you could monitor I think it's called approximate age of all that message in SQS, and something that is like the iterator age in Kinesis. So if you're using Kinesis, you have a similar concept there. But that's something you can monitor to see if your workers are doing their job fast enough so that you don't keep accumulating messages. Because of course, if you accumulate more messages than you can process in a reasonable amount of time, like eventually you're not going to be able to process these messages fast enough anymore. So your users will wait more and more before they can get results. So that those are other good things to explore, and maybe have some alarms to make sure things are being done efficiently enough.
Yeah, and if you're into like continuous deployment and continuous delivery, one of the other things that just springs to mind is that you can tie your alarms into your deployment process as well. And this is particularly useful if you're doing like canary deployments, blue-green deployments, where you need to monitor the health of the application if you're shifting traffic or percentage of traffic from one deployment to another. And CloudWatch alarms are ideal for that because you can get programmatic access to the state of the alarm. And it's also well integrated into Code Deploy and CloudFormation. So those tools will actually integrate into your alarms, start shifting traffic over to a new container or a new instance. And if the alarm starts to fire, it'll say, okay, let's back off here and shift back to the old instance. So it gives you deployment safety as well. Maybe that's something we can go into in depth in another future episode. Are there any kind of drawbacks with CloudWatch alarms? What's the first user experience like? What do you think for people getting started with CloudWatch alarms, and how could it be improved?
Yeah, I don't know if I would call it a drawback, but one thing that I wish was a little bit better with CloudWatch is that you don't really get anything out of the box. Like, you get all these amazing features, you can do a lot of things, but literally you start with a blank slate, and it's on you to define which things to look for and create all the alarms. And if you haven't done it before, it might be a little bit stressful to just come up with different use cases and make sure things are finely tuned. And for that, AWS just gives you like the well-architected framework, for instance, but gives you documentation that can give you ideas on where to start and what to look for. But again, it's all on you to do the hard work of configuring everything. And sometimes you create, for instance, serverless application using maybe the serverless framework. It feels a little bit unnecessary that you have already defined everything with infrastructure as code. Why not apply those best practices?
Exactly.
By taking that information that is already available in your source code, seeing, for instance, that you are using Lambdas, you are using SQS, why not creating all the out-of-the-box default alarms based on your infrastructure? And I wish that was available, and we have been spending a lot of time ourselves on this problem. And because of that, we ended up creating a serverless framework plugin that does exactly that. So it looks into your infrastructure as code, so your YAML file, your serverless YAML, and if it sees, for instance, that you're using a Lambda, it will provision for you a bunch of alarms that make sense for Lambda. Similarly, if you're using step functions, API Gateway, DynamoDB, Kinesis, SQS. And what we did is we are going to give you, with that plugin, you just initialize it, you get a bunch of defaults, but of course you can configure it a little bit more if you want to change the default thresholds, or if you want to enable or disable specific alarms that are a little bit more advanced.
That's a good one. And I guess it creates dashboards as well, so it also gives you kind of a little bit of a better user experience in terms of how those graphs of metrics are organized. I don't think it's worthwhile to have a dedicated episode on CloudWatch dashboards, since they're really just a representation of your metrics, and they can also show alarms as well. But it's another feature of that plugin. So when you deploy a serverless stack, you'll get a dashboard for that stack. So maybe it's a good idea to wrap up, just talk about cost. And you get 10 metric alarms for free, which is nice of them. But beyond that, it can get expensive if you've got a lot of them, right? So I guess your mileage will always vary depending on your context and usage. You're talking about 10 cents per alarm metric. Now, if you're using high resolution alarms, so high resolution alarms are alarms based on high resolution metric. So those 1 second metrics we talked about in the last episode. So those are $30. And if you have composite alarms, for some reason they're 50 cents for a composite alarm. And I don't know why the composite alarm implementation is so complex that it justifies that cost. It seems like a pretty expensive Boolean expression evaluation.
Mm-hmm.
But that's the cost you're dealing with. So if you've got, tens, dozens of alarms, that's probably, for most organizations, revenue generating organizations, is probably okay. But if you're starting out and trying to keep everything free tier, it's definitely something to keep an eye on. So at this point, I think we've covered now from the last 2 episodes metrics fairly in depth and what you can do with those in terms of creating alarms. Next one, I think we can talk about logs, log aggregation, and how in particular you can now use CloudWatch logs to get a lot more and maybe avoid having to use a centralized log aggregation service. Logs is probably my favorite topic of the 3, so I'm looking forward to that one. But if you haven't checked out the previous episode on CloudWatch metrics, check it out. It's episode number 33. And let us know what you think, and like and subscribe, and we'll see you in the next one all about logs.